Hi everyone, in this video we'll cover ERC165, also known as Standard Interface Detection. It introduces a meta interface to check if a contract supports an interface or not. So to understand this video, you should already know about the basics of Solidity and the basics of Ethereum. If you don't know them or you need a refresher, I have covered these in respective series called ETH001 and 002. You can check it out. And it's also recommended that you have some understanding of ERC20 token. So I have a separate video in the same video series covering that topic. You can check it out as well. So in this video, we'll cover the problem that we are trying to solve with this ERC165 standard, the solution itself, interface identifiers, implementing and using this ERC standard, a walkthrough of the EIP, and a walkthrough of the code. In very layman terms, ERC165 is a standard to detect and publish what interfaces are implemented by a smart contract. It standardizes a few things like how interfaces are identified, how a contract will publish the interface it implements, how to detect if a contract implements the ERC165 or not, and how to detect if a contract implements any other given interface. Now let's try to understand the problem that motivated the Ethereum community to come up with this ERC. So for some standard interfaces like the ERC20 or ERC721 interface, it is sometimes useful to query whether a contract supports the interface or not, and if it does, which version of the interface it supports. This will help us in understanding how to interact with that contract. This is useful if we want to interact with a contract, but we don't know if it supports an interface like ERC20 or ERC721. So if we send tokens to a contract that don't support these tokens, our tokens can get locked in that contract forever. So now that you have understood the problem correctly, we'll understand the solution. So since we are having a difficulty in identifying whether a smart contract supports a particular interface or not, the solution that people came up with was to create some interface identifiers to identify each interface. Then they came up with a way to check the interfaces implemented by a particular contract using the identifiers for those particular interfaces. Now, how this is done, we'll take a deeper look into that later. Let's first try to understand how interfaces are identified. So, any interface is a set of function signatures. So, if you recall what interfaces are basically a set of function definitions that a contract will inherit and implement. So, interface ultimately becomes a set of function signatures. Now, each function signature is identified by a function selector. This function selector is nothing but the first 4 bytes of the KCAC 256 hash of the function signature, and we derive the interface identifier from these function selectors. So interface identifier is the XOR of all the function selectors of an interface. Do note that optional functions are excluded. So if you have understood how ERC721 or ERC20 tokens are specified, you will realize that there are some core functions and then there are some metadata functions. The metadata functions and properties are optional, so you can exclude them. And generally, if you have looked into the implementation of OpenZeppelin as well, you'll see that ERC20 tokens and ERC720 tokens have two different interfaces. One is the core interface and the other is the metadata interface. So both of them would have different identifiers. So I found this great Medium article by, I don't know how to call this person, but yeah, it's a great Medium article on ERC165, and I'll add the link in the description below. So in this article, they have explained the function selector by giving a code example, and this is the code example. So in this example, basically they are defining an interface called Solidity 101, and it has two functions, hello and world. So this is an interface with two functions, and both of these functions would have their own function selectors, and then they are creating a contract called selector where they are calculating the interface ID of Solidity 101. So if you understand how interfaces are used in Solidity, you'll get this code snippet here. So we'll move on to the second function. In this function, get hello selector, we are fetching the selector of the hello function of Solidity 101 interface. So we are creating an instance of Solidity 101 interface, and then we are returning i.hello.selector. So this basically returns the selector, the function selector of the hello function from interface Solidity 101. So this would be the function selector for hello function, and similarly we are getting the selector for the world function. So these two would be the function selectors for hello and world functions respectively. And when we do a bitwise XOR of both of these function selectors, we get another value that basically is a representative of the interface Solidity 101. So this becomes the interface identifier for interface Solidity 101. I'd recommend you guys to pause the video here, open this article and go through this code snippet once so that you understand how it's working. If you understand this, you will understand how interface identifiers are created from function selectors. Now there was another point in the slide where I mentioned that interface identifier don't include the optional functions. So if you recall from the ERC20 video, you'll remember that ERC20 had a core standard and then it had an extension for a few optional properties. So we had a core ERC20 standard and then we had an extension called ERC20 metadata. So in the core ERC20 standard, we had these functions transfer, approval, total supply, balance of, transfer, allowance, approve, transfer from, etc. Sorry, these were events. So we had two events and these functions. And then in the metadata extension, we had some additional functions called name, symbol, and decimals. So these two are different interfaces. IRC20 would be a different interface and IRC20 metadata would be a different interface. So both of these would have different IDs. There's also this section in the official Solidity documentation. I'll add a link to this section. This briefly describes what function selectors are, and I've already covered what's there. But if you want to give it a read, I have given a link to this in the description. Now, the next question is how a contract will publish the interface it implements. So, we have an interface called ERC165 implementing this standard, and it will contain a function called supports interface. So this function will basically take in an interface ID and return some boolean value. You can override this function to return value true if interface ID is this value. This value represents the interface ID for IERC165. You'll have to return false for the interface ID value equal to this. You will return the value true for the interface ID value that represents the interface ID of any other interface implemented by the contract. So for example, if your contract is inheriting or implementing the ERC20 or ERC721 standard, both of these standards would have their own interface IDs, and you'll check if the interface ID is equal to the interface ID value of these standard, you'll return the value true. And for any other value, by default, you'll return false because your contract isn't supporting those interfaces. We'll also see how to detect if a contract implements ERC165 or any other given interface. So basically, first, before checking for any other interface, you'll check whether a contract implements ERC165 or not. So for that, you will find a supports interface function. If that is there, you can use that function to check for other interfaces. You'll have to get the interface IDs for other interfaces and use the supports interface function of ERC165 to check if your contract or if the contract that you are interacting with supports those interfaces or not. And if you aren't able to find the supports interface function, then you are basically screwed. You'll have to dig deep into the code base to understand what all interfaces are supported by the smart contract you are trying to interact with. If it is an open source GitHub repo, you'll still be good because you can view the code. If it is not, you'll have to go to Etherscan and figure everything out, which is actually very bad. Okay, so now we'll look at some code examples. ERC165 is there in the OpenZeppelin contracts module. It is included under the title of introspection. So you have the interface of ERC165 and then you have the implementation. So you can see that the interface of ERC165 is very simple. You are defining an interface and then you are including the function supports interface, which takes in the interface ID and returns a Boolean value, as we discussed. Now coming to the implementation, you see that we are importing the interface of ERC165 and then we are implementing that by overriding the supports interface function. So here we are adding a logic where basically we are checking if the interface ID is equal to the interface ID of the ERC165 interface. So we get that using this type and IERC165 in bracket and then fetching its interface ID. So this basically checks if the interface ID sent with this function call is equal to the interface ID of ERC165 or not. So this is the basic implementation. To check for multiple interfaces, we'll refer back to our Medium article again. If you scroll down below, you'll find this example where they have taken the ERC721 token as an example. So basically, if you want to check if a contract supports the ERC721 and ERC721 metadata interface or not, you basically override the supports interface function just like we did in our earlier example. And you'll also check if the interface ID is equal to the interface ID of IERC721 or IERC721 metadata. So basically, if you read through this snippet, this portion would return true if the interface ID is equal to the interface ID of IERC721. This statement will return true if the interface ID is equal to the interface ID of IERC721 metadata, and this statement will return true if the interface ID is equal to the interface ID of ERC165. So if any of these three statements is true, you will get the return value as true. So you can check for all three of the values individually. So now that you have a better understanding of what ERC165 is all about, you can go through this official EIP or ERC165 documentation easily. You can find it at this link, or I'll add the link in the description below. So you'll be able to go through this interface documentation without any issue. Most of the things here I have already covered. Do go through the code examples. They have some test cases. Do go through these test cases. They have some examples of implementation. So do go through this code snippet as well. You can see that here's a slightly different code snippet for implementing ERC165. So you can take this as a homework. Try to understand how this snippet is working and let me know in the comments if you figure it out. So that was all there is to this ERC165 standard. Check out this official documentation for more details about this standard. Check out the ERC165 or introspection video in my OpenZeppelin series. I have a different series covering all the OpenZeppelin contract modules. So you can check out the introspection or ERC165 video there. Also, check out how this standard is being used in the ERC721 and ERC1151 standards. So I have a video explaining each in this series only. So do check it out. Ask your doubts or leave feedback in the comments. Like, share, and subscribe. Thanks for watching, and I'll catch you in the next.